Good evening, guys. So, shall we get started?
Yes, sir.
Okay.
Yes, sir.
Any doubt from yesterday's topic or yesterday's exam?
No doubt.
Easy only, right? So, shall we move on to the next part that is called as the scalar or dot product of vectors. So, if two vectors are given to you, right? So, under product of two vectors, you have two types of multiplication. One is called as dot and the second is called as cross. So, the dot product is also called as scalar product because when you do the multi product between two vectors using dot, then the output that you get is a scalar quantity. Listen to this carefully. If A vector and B vector are two non-zero vectors, then A vector dot B vector is equal to magnitude of A vector into magnitude of B vector into cos of the angle between both, that is cos theta. Okay, so if you observe, magnitude of A vector is a number, magnitude of B vector is a number, and cos theta is also a number. So this is the basic definition of the dot product between two vectors. Is that clear, guys? Is that clear? So that is a basic definition. This is the first point that you're supposed to write. So I'm not giving you the logic of why this has come and all those things. This is how it is defined. Okay, because it comes from the concept called as projection. Once I explain projection, you will be able to think about it, but don't worry much. This is how the definition starts and make a note of it. That's it. So if I take, if either A vector or B vector or theta, so if either A vector is 0 or B vector is 0, then what you can say is theta is not defined, and in this case we can say A vector dot B vector is equal to 0. So you have two vectors A and B. If either of the vectors is 0 vector, then A vector dot B vector is 0. Okay. Now, the observations are, if you do the dot product between them, A vector dot B vector, if it is a real number. Guys, tell me one thing. If you already know this exercise, right? So I'm teaching with the assumption that you don't know this. If you already know this, I'll go a little faster and concentrate more on problems based on your inputs. What do you want me to do?
Problems.
You want me to
We'll
go faster? I'll go to problems. Yeah?
Yes, sir.
Okay. So I just want to confirm with one person. Raghavi, are you there? Okay. Guys, everyone is fine with this? Shall I go on to problems?
Yes, sir.
Okay. But just to ensure that you know the formula at least, let me teach. Let me at least read the points that are there, then I'll do the problems. Then I'll tell you the techniques. Suppose you take A vector and B vector to be two non-zero vectors. Then if A vector dot B vector comes out to be 0, then what can you conclude? So if A vector dot B vector is 0, then you can conclude that the vectors are perpendicular. So this is actually the condition for perpendicularity. So what is the condition for perpendicularity of two vectors? A vector dot B vector is 0. Okay. Similarly, if theta is equal to 0, then what can you say? A vector dot B vector will be equal to magnitude of A into magnitude of B vector into cos of 0 degrees, which is magnitude of A vector into magnitude of B vector. Okay. Similarly, if I do the dot product between the vector itself, then what will I get? I'll get A square. A square is nothing but magnitude of A square. Suppose if theta is equal to pi, then I get A vector dot B vector as minus of magnitude of A vector dot into magnitude of B vector, because cos of pi is -1. Okay. So from this, we can understand the fact that if you do the dot product between I cap dot I cap, J cap dot J cap, and K cap dot K cap, you will get the answer as 1, because I cap dot J cap, I cap dot I cap is what? Magnitude of I cap into magnitude of I cap into cos of 0 degrees. This will be 1 into 1 into 1. So that is why it is 1. Whereas if you take magnitude of I cap dot J cap, that comes out to be 0. Okay. And the last but one important property that you're supposed to know is, if A vector dot B vector is equal to magnitude of A vector into magnitude of B vector into cos theta, where A and B both are non-zero vectors, then you can always measure the angle between them as A vector dot B vector divided by magnitude of A vector into magnitude of B vector. Okay. And the last one is, the scalar product is commutative, in the sense A dot B is the same as B dot A. And the last two important properties that we need to understand are A dot B plus C is equal to A dot B plus A dot C, which is called as the distributive property. And A dot B, if there are two vectors, A and B are two vectors, then L be any scalar. Actually, it should be lambda. Then lambda be any scalar, then lambda times A vector dot B vector is the same as lambda into A vector dot B vector is the same as A dot lambda into B vector, because lambda is just a number. Okay. Next is, if A vector is given as A1 I cap plus A2 J cap plus A3 K cap, and B vector is given as B1 I cap plus B2 J cap plus B3 K cap, then A dot B is equal to how much? A1 B1 plus A2 B2 plus A3 B3. So this is what happens. Okay. And the last concept with respect to dot product is projection of a vector on line. Can someone tell me what is the meaning of projection of vector on a line? So you have a line and you have a vector. If you want to project this vector on the line, what are we supposed to do? From the ends of the vector. Yes, projection means dropping perpendiculars. The distance between the foot of the perpendiculars dropped from the vector onto the line is what is called as projection of vector on line. Then how much is it going to be? So projection of A vector on B vector is given as A dot B vector divided by magnitude of B vector. This one alone, let me prove it. Okay. Say this is A vector and this is B vector. Okay. If I extend it in the backward direction, then I get this as theta. Correct? So from here, if I drop a perpendicular, then this angle is also going to be theta. Correct? Then how much is this distance, guys? So distance between A and B is how much? It is A cos theta. Accepted? And that AB is what can I call it as projection? Because what it is, a projection is basically the distance between the foot of the perpendiculars. So AB is equal to A cos theta means, understand, we know that A vector dot B vector is equal to magnitude of A vector into magnitude of B vector into cos theta. Correct? So this A cos theta, if I call it as projection, then A cos theta will be equal to A vector dot B vector divided by the magnitude of B vector. That is what is given as the formula. So the projection of A vector on B vector is A dot B divided by the magnitude of B. So how to remember this is, projection of A on is there. No, whatever is the vector after that on, that will be in the denominator. So if suppose I put a question, projection of B vector on A vector, what will you say? Projection of B vector on A vector is what? A vector dot B vector divided by magnitude of A vector. Correct? This is how you're going to solve. So having all these things in mind, we will try solving the problems. Yeah? Clear, guys? Everyone is clear? Just give me a confirmation.
Yes, sir.
Perfect. So let us start. Find the angle between the two vectors A and B with magnitudes 1 and 2. So magnitude of A vector is 1, magnitude of B vector is 2, respectively, when A vector dot B vector is equal to 1. So how to find the angle? I told you cos theta is equal to A vector dot B vector divided by magnitude of A vector into magnitude of B vector. So A vector dot B vector that is, they have already given that value is 1 divided by magnitude of A vector is 1 and the magnitude of B vector is 2. So half. So cos theta is equal to half. Theta will be equal to pi by 3 radian. Okay. Find the angle theta between the vectors A and B. So how to solve this? Again, the same formula, cos theta is equal to A vector dot B vector divided by magnitude of A vector into magnitude of B vector. Then cos theta will be equal to A dot B is how much? 1 minus 1, sorry, 1 minus 1 minus 1 divided by square root of 3 into square root of 3. This and this will get cancelled, 1 divided by 3. So theta will be equal to cos inverse of 1 divided by 3. Oh, sorry. So cos inverse of minus 1 by 3. Example 15. A vector is 5i cap minus j cap minus 3k cap. B vector is I cap plus 3j cap minus 5k cap. Then show that the vectors A plus B and A minus B are perpendicular. So how to solve this? So what is A vector plus B vector, guys? It is 6i cap plus 2 8. So what is A vector minus B vector? It is 4i cap
4i cap
plus 4j cap minus 2k cap. Sorry, plus 2k cap. Right. So this I call it as C vector and this I call it as D vector. If two vectors are perpendicular to each other, then what is the condition between them?
Dot product will be 0.
Dot product should be 0. So dot product is it 0? So when I do the dot product between both,
That
I
will
get
be minus 4j cap, right, sir? So A vector minus B
where?
vector. 4i cap minus 4j cap is 2.
Oh, minus other. So 24 minus 16 is 24. This will get cancelled. Answer is 0. Sixteenth. Find the projection of vector A on vector B. So what is it? A on B means A vector dot B vector divided by magnitude of B vector. So what is A dot B? Tell me, guys. 2 plus 6 plus 2, the whole divided by square root of 1 plus 4 plus 1. So it will be 10 divided by root of 16 or 10 by 4. 10 by 4 is, they make any mistake? Oh, root 6, sorry. So if you rationalize it, you get 10 root 6 divided by 6. So 5 and 3, 5 root 6 divided by 3. Okay. Then example 17. Find the magnitude of A vector minus B vector if the two vectors A and B are such that magnitude of A is 2 and the magnitude of B is 3 and A dot B is 4. Okay. Find magnitude of A vector minus B vector. So what we will do is consider magnitude of A vector minus B vector square. So magnitude of a vector square is nothing but the dot product between those two vectors. That is A vector minus B vector dot A vector minus B vector. So this will come out as A square plus B square minus 2 times A vector dot B vector. Did you guys understand? Because A vector dot A vector is A square. Minus B vector dot minus B vector is plus B square. Minus 2 times A vector dot B vector. So A square is 4. B square is 9. Minus 2 times A vector dot B vector is 4. So 13 minus 8 is going to give you 5. Then what will be the magnitude of A vector minus B vector? That will be root 5. Don't put plus or minus because magnitude can't be negative. So this is the answer. Any doubt?
No,
No,
no.
sir.
Simple, right? If A vector is a unit vector, then x vector dot x vector minus A vector dot x vector plus A vector is 8. So x square minus A square is 8. Then find the magnitude of x vector. It's simple. X square minus what is A square? 1. Because A is a unit vector is equal to 8. So x square is equal to 9, which implies x is equal to plus or minus, x is equal to root 3. Why is it root 3? Because magnitude can't be negative. Similarly, for any two vectors, A vector and B vector, we always have magnitude of A vector dot magnitude of B vector, magnitude of A dot B less than or equal to magnitude of A into magnitude of B. This is also called as Cauchy-Schwarz inequality. So it's very simple, okay? We know that cos theta is equal to magnitude of A vector, cos theta is equal to A vector dot B vector divided by magnitude of A vector into magnitude of B vector. If I take modulus of cos theta, then what will I get? Magnitude of A vector dot magnitude of B vector by magnitude of A into magnitude of B. And we know that cos theta is always less than or equal to 1. When that is the case, this will go to the other side. So magnitude of A vector dot B vector is less than or equal to magnitude of A vector into magnitude of B vector. Okay. Similarly, if you take any two vectors A and B, we always have magnitude of A plus B less than or equal to magnitude of A plus magnitude of B. Okay, wherever you see this magnitude thing, right, with some more difference, first is consider the square of it and apply dot product. So that will be A vector plus B vector dot A vector plus B vector. So what will I get? A square plus B square plus 2 times A vector dot B vector. So what is A square? Wait. For any even, okay. Okay. Two times. Okay. So I'll have magnitude of A square plus magnitude of B square plus 2 times. Can I write it as A vector dot B vector? Did they give that A and B both are positive? So for any two vectors A and B, listen, if I take magnitude of A vector plus magnitude of B vector square, then what will I get? That will be A square plus 2 times A. So what is the difference between this and this? Guys, I asked a simple question. What is the difference between the one which is there in blue and the one which is there in light blue?
And that's A vector dot B vector. So
Here it is the dot product between A and B. Here it is the product of magnitudes of A and B. So from the previous property, can I write if I take this as magnitude of A square plus magnitude of B square plus 2 times magnitude of A vector dot B vector, then this is less than or equal to magnitude of A square plus magnitude of B square plus 2 times magnitude of A vector into magnitude of B vector. Why did I write it like this? Because I know this property that is there, no. This is the property that I used it in this problem, Cauchy-Schwarz inequality. So when I do that, then I can say magnitude of A vector. So this thing is directly related to this. So magnitude of A vector plus B vector the whole square is less than or equal to magnitude of A magnitude of B vector the whole square. When that is the case, then magnitude of A vector plus magnitude of B vector is less than or equal to magnitude of A vector plus magnitude of B vector, and that is what we were supposed to prove. Actually, you know what is the meaning of this? Sum of two sides of a triangle is always greater than or equal to the third side. That is why this is also called as triangle inequality. Okay. So show that these vectors are collinear. So find out AB vector. So what is AB vector? 3i cap minus j cap plus, sorry, not plus, minus 2k cap. So what is BC vector? 6i cap minus 4k cap. What is AC vector? 9i cap minus 3j cap. Did I miss anything? 6i cap minus 2j cap minus 4k cap. So 9i cap minus 3j cap minus 6k cap. Correct? So how to prove that they are collinear? By looking at, we can say, so you see AB vector and BC vector, they're in what ratio? BC vector is equal to 2 times AB vector. BC vector is 3 times AB vector. Can I write it like this? Yes or no?
Yes, sir.
So that's it, they're collinear. Okay. Now, find the angle between the two vectors A vector and B vector whose magnitudes are this much, B is this much. So A dot B is this much. So cos theta is equal to, directly tell me, I'm not writing the formula, root 6 divided by root 3 into 2. So there's going to be root 2 by 2 or 1 by root 2. So what will be the value of theta? Theta will be 5 by 4. Correct? Second, see if you observe, no, the order of examples will be followed here, nothing else. So find the angle between these two vectors. So cos theta is equal to A vector dot B vector. So 3 minus 4 plus 3 divided by square root of 1 plus 4 plus 9. Square root of 14 into square root of 9 plus 4 plus 1. That is also square root of 14. So 3 plus 3, 6. 2 divided by root 28. 2 divided by root 28 means 28. I can write it as 4 into 7. So it is 1 by root 7. Cos theta is this thing. So theta will be equal to how much? Cos inverse of 1 by root 7. Third, Find the projection of this vector on the other. So what is the answer? A vector dot B vector divided by magnitude of B vector, where this is A, this is B. So this will give it 0 divided by root 2. So it is 0. The answer came out to be 0 because they both are perpendicular vectors. So you cannot project perpendicular vector onto another vector. Fourth one, find the projection of this on the other vector. So answer A dot B. So 7 minus 3 plus 56 divided by root of 49 plus 1 plus 64. So whatever is the answer calculated, that will give you the projection. Okay. Show that each of the given 3 vector is a unit vector. How will you show them? How will you show that they are unit vectors? Gods, please answer. I asked a simple question. How are you going to prove
So
it?
the answer is
The
0.52.
magnitude will be equal to 1.
Equal to 1. Just find the magnitude and equal to 1 and show that they are mutually perpendicular to each other. If I take this as A vector, B vector and C vector, then A dot B should be equal to B dot C, should be equal to C dot A, should be equal to 0. Okay, what is A vector dot B vector? 6 minus 18 plus 12 divided by whatever it is. So 18, this will come out to be 0. You will concentrate on numerator. B vector dot C vector, how much is it? 18 minus 12 minus 6. This will be 0. C vector dot A vector. 12 plus 6 minus 18. This is also 0. Right. Sixth one. Find magnitude of A vector and B vector if this is the case. So I can write magnitude of A square minus magnitude of B square is equal to 8. And magnitude of A is 8 times B. Appa idu evlo? 64 B minus B square is equal to 8. Correct? Did I make it A square minus B square plus A dot B minus A dot is equal to 8, and A is already 8 times B. So 64 B square minus B square is equal to 8. So 63 B square is 8. So B square is equal to 8. 63 அப்ப B எவ்வளவு இருக்கும்? Root 8 divided by root
2 by root 63.
Then can you find A now? A will be 8 root 8 divided by root 63. Okay. Seventh one. Evaluate the product. So 3 into A vector dot 2 into A vector. It is 6 into A square. 3 into A vector plus 7 into B vector. That is 21 into A vector dot B vector. Minus 5 into 2. So 10 into B vector dot A vector minus 35 into B square. So 6A square minus 35B square minus, sorry, plus 11 times A vector dot B vector. Okay. Eighth one. Find the magnitude of two vectors A and B having the same magnitude and such that the angle between them is 60 degrees and their scalar product is half. So how to do this? Magnitude of A vector is equal to magnitude of B vector. We call it as A itself. To half, and theta is equal to 60 degrees. So A vector dot B vector is equal to magnitude of A vector into magnitude of B vector into cos theta. So A dot B is half, magnitude of B is 0. That's what we need to find. So magnitude of A cos 60 is again half, cancel it. So magnitude of vector is 1. That is the answer. Ninth one, find magnitude of x vector in this case. So x square minus a square is equal to 12 and a is a unit vector. So x square is equal to 13, x will be equal to root 13. Tenth one, a vector is this much, b vector is this much, c vector is this much are such that a plus lambda b is perpendicular to c. Then find the value of lambda. So a plus lambda b is 2 minus lambda I cap plus 2 plus 2 lambda j cap plus 3 plus lambda k cap. This is perpendicular to c vector. So c vector is 3 I cap plus j cap. It is perpendicular means what are we supposed to do? 6 minus 3 lambda plus 2 plus 2 lambda should be equal to 0. Correct? Huh? So 6 plus 2 is 8. 8 minus lambda is 0, which implies lambda is equal to 8. Give me a second. So what is the problem number 11th?
Before this.
This one, right? So 10th one we finished, no? Lambda is 8. So,
Yes, sir. So lambda.
11th we will do. So this is one vector, this is one vector. They both are perpendicular, so that we need they are perpendicular to each other. Remember, magnitude of a vector is a number and magnitude of b vector is a number. So when I do magnitude of, or I will write it like this instead of taking that magnitude, ab vector plus ba vector dot ab vector minus ba vector. When I do this, I get a square b square minus b square a square. That is obviously a 0. Did you understand what I did? A vector
Yes,
dot
sir.
a vector, yeah, a vector dot a vector is 0, a vector dot b vector is 0. Then what can you conclude about the vector b? See, a dot a is 0. What can you say about that? Then magnitude of a square is 0. Then magnitude of a vector is 0. Whereas in a dot b, what can happen?
Can be or
It is,
cannot be 0.
Either of A or B can be 0, sir.
no, it cannot be. Because if this is already given, means magnitude of a vector is already 0. Then what can b vector be? Then what can be concluded about b vector? B vector can be any non-zero vector. Because when I do a dot b, I get magnitude of a into magnitude of b into cos theta. But already the magnitude of a is 0, that we have already concluded. Correct? When you have concluded, then b vector can be in such a way that it can be any non-zero vector.
But why can't B vector be 0? Sir?
Okay, it can be a 0 vector also. It can be a 0 vector also, but there is a probability. That's it. It can be any vector.
So I have a doubt, sir.
Tell me.
So suppose A vector is still a 0 vector, then can we still say B vector is perpendicular to A vector also?
I cannot know, because 0 vector, how will you define the direction?
Origin, sir.
Only lines can be perpendicular. Zero vector is a point. A point and line cannot be perpendicular. You able to understand? Rohan, are you able
Yes,
to
I
understand what?
understand.
So A vector, B vector, C vector are unit vectors. So the magnitude of all is equal to 1, such that A plus B plus C is equal. Then find the value of A dot B plus B dot C plus C dot A. So whenever you have this kind of a thing, right? So mark it as important. This is zero vector, no. So take the magnitude on both the sides and square it. Because when vectors are added and they're asking you about the dot product between those vectors, the only way to get is by squaring them and doing the dot product of the vector with itself. So when I do the dot product of A vector plus B vector plus C vector with itself, then what I'll get is A square plus B square plus C square plus 2 times A vector dot B vector plus B vector dot C vector plus C vector dot A vector is equal to 0. So A square plus B square plus C square is 3. So 3 plus 2 times A vector dot B vector plus B vector dot C vector plus C vector dot A vector is equal to 0. So what is the answer for this? If I call this as x, x is equal to minus 3 by 2. Am I clear? Yes?
Yes, sir.
14th. If either A vector is equal to 0 or B vector is equal to 0, then A dot B is 0. But the converse need not be true. Justify your answer with example. So we know that if A vector is 0 or B vector is 0, then A vector dot B vector can be taken as 0. But what is the converse? Converse says if A vector dot B vector is 0, then either A vector is 0 or B vector is 0. This is the converse. The reverse means if this condition is true, then we are trying to say that these two are true. It is not possible.
Not possible because cos 90, when even if the both are not
Yes.
0, cos 90 might make them 0.
If those two vectors are non-zero, but still A vector dot B vector can be 0 just because they are perpendicular to each other. So the converse is not true. Okay. So that is 23rd. So 24th, if A, B, C are the vertices of the triangle, so this is a position vector. So I cap plus 2j cap plus 3k cap. And this one is minus I cap plus 0j cap plus 0k cap. And this one is 0 I cap plus j cap plus 2k cap. Okay. Respectively, then find angle ABC. So this is A, B, and C. What is AB vector? Minus 2i cap, minus 2j cap, minus 3k cap. What is BC vector? I cap, I cap plus j cap plus 2k cap. So why I found AB vector? I'm stopping with this. I'm not finding AC vector because they asked us to find the angle B. So when they asked us to find the angle B, the vectors should be in such a way that the ending point of the first vector and the starting point of the second vector should be same. So if you take that, then cos theta will be equal to AB vector dot BC vector divided by magnitude of AB vector into magnitude of BC vector. So how much will you get? Minus 2 minus 2 minus 6, the whole divided by root of 4 plus 4 plus 9, 13 plus 4, 17 into root of 1 plus 1 plus 4, 6. So this is going to be minus 10 divided by root of 17 into root 6. So theta will be equal to cos inverse of minus 10 divided by root 17 into root 6. That's the answer. Okay. I hope I'm clear, right?
Yes, sir.
Show that the points are collinear. So find AB. So AB vector is equal to 2 minus 1 I cap plus 4j cap minus 4k cap. Did you guys understand how I wrote it directly?
Yes, sir. OB minus 1.
It's simple, right? So BC vector is I cap plus 4j cap minus 4k cap. And AC vector is equal to 2i cap plus 8j cap minus 8k cap. So AB vector and BC vector, they are the same, hence they are collinear. And AC vector is equal to 2 times AB vector. So they are collinear. In your textbook, I think they would have taken magnitude of AB plus magnitude of BC is equal to magnitude of AC. That is also right. That's what you would have done in your 10th standard. Right. Next. Show that the vectors form the vertices of a right angle triangle. So yesterday we did a problem, no? When you had to show that they form the vertices of right angle triangle, what did you do? You found using Pythagoras theorem, right? Now what we can do is you can use the dot product. So if I take this as A, B and C, what is AB vector? Minus I cap plus minus I cap minus 2j cap minus 6k cap. So what is BC vector? 2i cap minus j cap minus 11 plus k cap. So what is AC vector? AC vector is I cap minus 3j cap minus 5k cap. So what you can do is take the dot product between any two vectors and one of them comes out to be 0. So AB dot BC, what is it? Minus 2 plus 2 minus 6, not 0. AB vector dot AC vector is how much? Minus 1 plus 6 plus 30, not 0. Then BC vector dot AC vector 2 plus 3 minus 5. So this is coming out as 0. So BC vector, so it is right angled at point C. So how I found it as point C is because that is a common point. So this is a right angle triangle which is having a right angle at point C. Am I clear? Last. If A vector is non-zero vector of magnitude A and lambda is a non-zero scalar vector, then lambda times A vector, the unit vector is lambda times A vector should be equal to 1. So lambda into magnitude of A vector is 1. So lambda should be equal to, or I can take this thing, no? Magnitude of lambda into magnitude of lambda into A is equal to 1. So A should be equal to 1 divided by magnitude of lambda. Actually, I could have avoided 2 steps. 8 times. Is it clear, guys?
Yes, sir.
That is the problem based on dot product. See, with respect to cross product, what I've done is I've already recorded a video, okay, which is there. I'll share the link in the group today. You guys go through the concept and come so that we can save time. And tomorrow's class, we can directly do problems like how we did it today. So tomorrow I'll complete vectors. Okay. So I'm hoping that there are no more doubts from this chapter, from this exercise. Correct? Shall I close it?
No doubt, sir.
No doubt,
Okay,
sir.
then
No doubt,
then we
sir.
can. Yeah, we'll wind up this.
Thank you, sir.
Thank you, sir.